many billions of years to create a galaxy, like the Milky Way galaxy, with 100 billion stars.
How do you measure the age of something that doesn't age? You might think that this is a simple question, but it's actually not. Measuring the ages of planets and stars is tricky, because they don't have birth certificates, or wrinkles, or grey hair. They just look the same for billions of years, like some celebrities who never age. Seriously, how do they do it? So how do astronomers estimate the ages of these space objects? Well, they use various methods that are based on subtle clues, assumptions, and, well, a bit of guesswork. Let's break down these methods and see how they hold up. One method is to compare the brightness and color of a star to mathematical models that predict how stars change over time. This sounds reasonable until you realize that these models are like trying to guess someone's age by looking at their photos on Instagram, without knowing anything about their filters, makeup, or plastic surgery. Another way to estimate a star's age is by looking at how fast it spins. Think of stars like cosmic race cars. They start out fast and furious, but then they get old and slow. But as they age, they slow down. This method has a name that sounds like a medical condition: gyrochronology. The problem with this method is that different stars have different initial spin speeds, and different factors can affect their spin rates, such as magnetic fields, stellar winds, and even other stars or planets that come too close can change their speed. It's like driving on a road full of bumps, traps, and traffic. Then there's the magnetic activity method, where astronomers observe stellar flares that decrease as a star loses its spin and magnetic field. Sounds cool, right? Well, here's the bad news. Magnetic activity can vary depending on a star's cycle and mood swings. Some stars even throw in surprise bursts or drops of activity that are not related to their age. Finally, we've got astroseismology, where scientists shake stars to study the vibrations on their surface. It's a bit like tapping a drum to hear its beat. These movements give us clues about the star's insides and age, but it's tricky because it requires extremely precise measurements, which can be challenging for distant stars. Also, it relies on complex theories that aren't entirely confirmed. So here we are with all these methods for stars, and none of them are absolute gold standards. But what about planets? How do astronomers estimate their ages? One way to find out the age of a planet is by using radionuclides. These are like candies that melt very slowly, but they're made of atoms. By checking how much of these candies are left, astronomers can guess how long they've been melting. This way sounds smart, but it has a big problem. You need to have a piece of the planet to do it, and that's not easy for most planets far away from us. Also, different planets can have different kinds and amounts of these candies in their rocks, depending on where they came from and what happened to them. Another way is to count the craters on the surface of a planet or its moon. You see, those craters are like battle scars from clashes with asteroids or comets over time, and the more you've got, the older you're considered. But this way is not perfect. Sometimes craters can be erased by erosion from water, lava flow, or covered by dust or ice. Also, different planets and moons have different impact rates and sizes depending on where they hang out in space and their gravity. Now you can see that estimating the ages of planets and stars is not a walk in the park, it's more like a maze with no exit. We can only guess that they're about as old as their stars, which are also hard to date. But why is estimating the age of planets and stars important? Does it matter if a planet is 10 million or 2 billion years old? Why should we care? These are good questions, and the answer is yes, it does matter. Knowing the age of a planet or a star can help us understand many things, such as how the universe evolved over time, from its explosive birth at the Big Bang to the present day. We can learn about the origin and history of matter, energy, and life in the cosmos, how planets form and change over time, and what factors influence their habitability. By comparing the ages of different planets, we can see how they developed different features, such as atmospheres, oceans, volcanoes, and plate tectonics. We can also see how long they've been stable enough to support life.
If life here is somehow related to comets bringing these wonderful rich organics here, it very well may have happened elsewhere in the solar system as well.
And what kind of life forms could have emerged on them? Now that we know why planets' ages matter, let's turn our attention to their stars. You know, stars are like the celebrities of the galaxy. They shine bright, attract attention, and sometimes have a meltdown. But By studying how old they are, we can guess what they will do next and how they will end up. We can also see how their planets deal with their stars' mood swings, such as bursts of energy, strong winds, and harmful rays. We can also see what happens to planets when their stars go out with a bang, as supernovae, or shrink into black holes. By estimating the ages of planets around other stars, we can also see what happens to planets when their stars go out with a bang, such as supernovae, or shrink into black holes. By estimating the ages of planets around other stars, we can assess their potential for hosting life. We can also see how long life has had a chance to evolve on them, and what kinds of life forms we might expect to find. So yeah, estimating the ages of planets and stars is not just curiosity. It's a way of exploring the mysteries of nature and our place in it. It's a way of finding out if we are alone or not in this vast and wonderful universe. But how do we know what kind of life forms might exist on other planets? How do we know what they look like, how they behave, and how they communicate? These are also good questions, and the answer is, we don't. We're only taking educated guesses. We don't have a handbook for alien creatures. Instead, we rely on a science called astrobiology. Astrobiology is like being a detective. It blends astronomy, biology, chemistry, geology, and physics to explore the possibility of life elsewhere. It helps us answer big questions. What's the essence of life? How did it all begin? Could life exist in other parts of the universe? And how might life adapt to different cosmic neighborhoods? We're also curious about how we'd even communicate with aliens if we met them. Now here's the exciting part. Astrobiology isn't just about lab experiments. It's an arena for letting our imaginations run wild. Astrobiologists have to dream up all sorts of wild scenarios. Think ice-covered oceans on Europa, creatures drifting in the clouds of Venus, or life on the strange landscapes of Titan. In the world of astrobiology, scientists also explore extreme environments right here on Earth. They go to deserts, dive into icy oceans, and investigate acidic volcanic springs. Why? Because these places resemble the tough conditions found on other planets and moons, where life could exist. Astrobiologists also study extremophiles, microscopic organisms that can survive in very harsh places. They can live in very hot places like volcanoes, geysers, or hot springs. They show us that life can handle almost anything. But how do astrobiologists go about finding clues and evidence for these wild scenarios? Well, they use a bunch of methods and tools to search for signs of life both near and far. For example, they use telescopes to peek at the stars and planets, looking for hints of water, oxygen, or other life-friendly stuff. They also send satellites, rovers, probes, and landers to snoop around the surfaces and atmospheres of other worlds, collecting samples and data that could show traces of organic molecules or tiny fossils. On Earth, they do experiments and studies that simulate and test different conditions that might affect life in other worlds. And speaking of other worlds, did you know that NASA might have accidentally found and destroyed an alien life form on Mars? It was very tragic, and you won't believe the details when you hear them. We actually made a video on this, and you can click here to watch it right now. It's worth it, trust me. Hey, before you go and watch that mind-blowing video, let me drop a line that'll make your day. Ready? Here it goes. If you liked this video, please show some love by hitting the like button, sharing it with your friends, and subscribing to our channel with the bell icon. I know it sounds like a cliche, but it really means a lot to us. Thanks for watching. See you soon with more cool space news.